Okay, so as we compare the original function and the reciprocal function, let's compare these these categories here, these columns. The absolute value of the function gets very large. So let's think about this. The function in red here, as the absolute value of the function, whoops, not in red. Anyways, as it gets very large up here, as it starts to increase and increase, what happens to the reciprocal function? The original graph gets very large. What happens to the reciprocal function? So let's say this is y equals 1. As this gets very large, what happens to the reciprocal? It gets smaller. Okay. Closer to x. Closer to x-intercept. Okay. Those are good guesses. They're not quite close. First of all, I heard getting smaller. Okay. It does not get smaller without bound. That means it doesn't just keep getting smaller and smaller, crossing 0 into the negatives. It doesn't do that. There probably is not going to be an x-intercept as well. There might not be an x-intercept because of the horizontal asymptote. So what goes in this box? The absolute value of the function gets larger. Absolute value of reciprocal approaches 0. Approaches 0. So it's just like this. It kind of comes towards the y equals 0 line, but doesn't touch it, and it doesn't cross it. Yeah, that's probably what you meant. That could be what you meant. But there technically is, for most, no x-intercept. Okay, for the reciprocal. Because remember, 1 over 0. Okay. All right. Now, when I say absolute value, let's keep this in mind. Absolute value, that means it gets larger on the positive side or it gets larger on the negative side. So it behaves this way on both sort of ends of it. Does that make sense? The absolute value, so that just means the number gets really large, either in the positive direction or the negative direction. That's what the absolute value is in there for. Okay, reciprocal values are positive. So if reciprocal values are positive, what can you say about the original function? Let's say these are the reciprocal values. And again, I should use different colors here. So here, hello, red. So these are the reciprocal values. They're positive. So what is that? What does the original function? How can you describe the values of the original function? They are? These are what, sorry? Well, remember, does the sign change when you take the reciprocal? Does it become negative or does it become positive? No, it stays the same. So original function values are positive as well. I should be careful over here making this distinction. There's an asymptote here. Okay, you jot this down there? Just be writing this down, but it's part of your notes, remember? All right, so the function values are negative. Function values are negative down here. So what does that mean about the reciprocal values? They are negative. Also negative. You guys are getting it? Also negative. Okay, so original function, here again, fx. The zeros of the function are the x-intercepts of the graph. So what can we say about the reciprocal function? So here's the zeros of the graph for the original function, f of x. What can be said then about those zeros right here for the reciprocal function? Non-permissible values. Excellent. Also, more specifically, what are they? Remember doing this? Vertical. The word is asymptotes. Asymptotes. Asymptotes as well. The stress could be on the different syllable. So non-permissible values, good. Non-permissible. And vertical asymptotes. Okay, so that's these right here. Okay, So on the reciprocal function, the value of the reciprocal function is y equals 1. So let's say this is 1 right here. The value of the reciprocal function is y equals 1. What does that mean about the original function? What's the value there? Anybody? Thank you. Yeah, it's 1. Okay. That was supposed to be the easiest one, I think. Okay? If you've got an original function, y equals 1 on the reciprocal, remember 1 over 1 is still 1. So if you've got 1 on the reciprocal, 1 over 1 is still 1 on the original. Okay? That's the easy one. Okay, moving on. Over here, absolute value of the function approaches 0. So that would be right here. It's approaching 0 over here. So what is happening to the reciprocal? Absolute value of the reciprocal, whoops, approaches what? As this graph approaches 0, the red graph would approach, right, it goes the other way, approaches 1 over 0, which is infinity. Okay? And we'll just call it infinity. That's the same as getting larger without any bound, right? Without any boundary. So it approaches infinity, and that's what happens to the graph as it kind of gets closer to the vertical asymptote. All right, the value of the function is -1. So what's the value of the reciprocal? Yes, the same. If it's 1, the reciprocal is 1. If it's -1, the reciprocal is -1. And that's the last part of those two columns there. Okay. Anything else that we can compare with these two graphs that you can think of that's not on this? Okay. So if you understand that, if you realize that, all these points here and how they relate to one another, that's more than half the battle right there. Okay.